there it goes. Okay, so substitution. And I'm not going to write down the steps to do substitution. I'm going to write down the sentences you should consider when you're choosing to do substitution. Okay? All right, substitution. Choose when one variable can be easily isolated. Okay, easily isolated. You have done substitution before. You have done elimination before. You did it with your linear systems in Algebra 1, where you tried to figure out whether you had two separate lines. 2x plus 4y equals 8, x plus 2y equals 3. Like, you have done systems before where maybe you added or subtracted the lines up, or maybe you solved, you easily isolated, and substituted. Okay? We're going to look at what happens when the systems get a little bit more complicated, as in non-linear. Parabolas, lines, parabolas, circles, and parabolas. Okay? Now there's two parts to this. The first part is choose substitution when one variable can be easily isolated. The second sentence is, and the resulting equation can be solved. You would like to be able to solve whatever happens after you do the substitution. Okay. We're going to focus on how these two sentences can help us choose substitution. What does it look like algebraically? So x minus 3 squared plus y plus 1 squared equals 9. Okay, then I'm going to say y minus x equals negative 1. Okay. Choose substitution when one variable can be easily isolated. Which one of these variables can be easily isolated? X, y, x. Y. Okay, I'm going to do my first sentence. What does it look like algebraically when something can be easily isolated? Y equals x minus 1. If I have a choice, I do put my positive part first. Okay, so I added x to both sides. Notice these are not like terms, so I just write them. Okay, I can easily isolate. Second sentence. The resulting equation can actually be solved. Okay, do the substitution and see what it looks like. I mean, it looks a little bit, okay, but I noticed that inside this parentheses, I've got a little bit of like terms I can put together. Okay. Okay. Can you solve this equation? Well, I only see an x, okay? I'm going to say one variable. It's kind of important that you have one variable left. And it's quadratic. Can you solve a quadratic equation? Yes. So, let's start solving. That means expand. Combine all your like terms. isolated. Okay, so like terms. Okay, so there we go. That's what I end up with. I can easily isolate the y, and when I substitute it, I am left with a quadratic equation. How do you actually solve a quadratic equation? Well, you have three choices: isolate, factor, or complete the square. All I did to get to this point here was I just expanded and combined my like terms. I'm going to try factoring because I see a common 2x. Okay, so I've got 2x coordinates. But this is a system. I need both x and y. So go back and get the y coordinate. There it is. Okay. I'm just copying down the equation I'm using to find my y coordinate. Okay, the solution to that system, which was a circle and a line, are these points right here. Okay. I didn't tell you how to go through the actual solving here. What I wanted you to hear was why I chose to do substitution. I chose to do substitution because I could easily isolate one of the letters, and when I substituted it, I ended up with a quadratic equation, which is something that I actually know how to solve. Then I actually solved it, okay? There's a lot of steps anyways, but you've got to be able to pick the right method. Okay, I'm going to give you one to try. You can do it on your whiteboard or you can put it in your notes. Okay, see if you can easily isolate and figure out what the resulting equation is. Try it. Okay, here is your question. Y plus 13 okay, there you go. Can you easily isolate? And what is the resulting equation gonna be? Okay. Show me this part before you do the next part. Show me what you're going to isolate before you actually move forward. Okay, actually isolate. Do the isolation. Yeah, like what would you get? X equals or Y equals? It does. It will affect the next step. One section is easier than the other. Yes. Yes. Okay. Yes. that. You're deciding, like, can you easily isolate? And then what does that substitution actually look like? Okay, because I want to see what you're thinking. Yes, okay, so the next step. Okay, and solve. Solve. Finish it.
No, it's negative x minus 1.
Okay, so this is where you have to be like, look at, if I can isolate, what is my substitution going to look like? What could I also choose?
Oh, yeah.
Okay. This is a decision making and solve. Keep going. Now keep going. All right, I'm going to write down my two choices. I can easily isolate this or this. They're like almost the exact same. But one choice is better than the other. This one is better. Guys, today is about choosing the method. It's not about getting through it, the algebra part. It's about choosing the right steps. This one, when I actually do the substitution, will look like this. Okay, that seems okay. What would it look like if I choose this method? Automatically, I don't like this. I don't want to square that. Do you see the difference? This is the better choice because it is simpler to actually substitute. Okay, I want you to actually continue this part and see if you can get all the way to the points. They will both work. One will be easier than the other. And sometimes one will not work. And so we have to look at the other possibilities. Not very nice. Right, it's possible. Okay, get all the way to your solutions. Yes. It should factor. 8 is 4 and 2. Check your signs. Check your signs. Okay. Put your 0 down. Plus x, minus 8. Okay, check your signs. You should end up with a minus 8. Okay, see if you can get all the way to the coordinates. Check your numbers. It should be 9. Yes. You should get integer coordinates. Check your numbers. Okay, look at how I combine. Yes.
If I have this and I add 3x to both sides, then it's negative x plus 3x.
But then you're going to minus x squared to both sides. You're going to have a negative in front. Okay, so it's not y equals. It's 0. 0.
Okay.
Yes. Okay. Yes. And then you factor. Okay, those are the x coordinates. Now find the y's.
What do you do after? Then you plug it in. So like, oh, because x
And
is 4.
think about which ones could be used for substitution easily. Right?
They're opposite.
Okay, so we get.
To do x minus 4 equals 0.
Okay, you should get the x coordinates of 4 and negative 2.
By negative 1.
You don't want to factor with the negative in
It
front.
becomes x squared minus 2x
Okay,
minus
check your steps.
and then 0 times negative 1.
Yes.
So just make it like
See if you can get all the way to the coordinates.
and then you well no, then you factor it. That's a negative 8.
Which ones you be the substitution for.
Wait, how did you get y?
Because we're going to look at any of these. Yes. Yes, like when we did the ABCs.
So I can plug it into y equals negative
Yes.
x.
You've done these methods, but now I'm putting squares in, which changes it slightly. Okay. Yes. All right, guys. So you get x equals 4. Look at that. Y equals negative x minus 5. Negative 4. Okay, so 1 point is 4, negative 9. Okay. 2 minus 5. Negative 3. Negative 2, negative 3. This happened to be a parabola and a line that crossed twice. Okay. How did you choose your substitution? And look at why I chose this path versus this path. There's almost no wrong way to do it, but one is easier than the other. So you have to predict 2 steps before you actually start. Okay? Just keep it for you. Okay, back to your notes. We're going to do elimination. All right. You will. Okay. I want to know why I would choose elimination versus substitution. You've done both with linear systems, but now we've got quadratics and circles and parabolas. And so we need to see what it looks like so we can make our choices. Okay. Choose when. Like terms for one variable can be scaled and eliminated by adding or subtracting two equations together. I know it's a really long sentence. Scaled means multiplying the coefficients. Okay? See this up here? It's when you added or subtracting the 2 equations together. For example, I see this on the board that if I multiply this by a, well, that was a bad choice. Hold on. By a 2, that I get 2, 6, 6. And when I subtract them, the x's are eliminated. This is what it used to look like. You can scale the equation so that when you add or subtract, one of the variables is eliminated. All right. There's a second part to this sentence. And the resulting equation will only have one variable, x or y. Only one variable will be left, x or y. You cannot have both of them left. It won't work. Okay, so what does this look like? Okay, 2x squared plus y squared plus 6x plus 6y. I'm not asking you to graph it. But what's different from last year, it's no longer just linear. It's squares, circles, parabolas. This is actually an ellipse. I'm not going to ask you to graph it. We're just going to solve it algebraically. I'm also trying to make a clear point about what this sentence looks like algebraically. Okay, so notice that all of my columns are like terms and they're lined up so I can easily compare them. Okay, choose when like terms for one variable can be scaled and eliminated by adding or subtracting. Okay, 2x squared and 6x squared. But notice that I'm going to look at all of the x's at the same time. Can you scale and eliminate all of the x's? Well, if I multiply by 3, scaling it, I can make my x squares match. If you multiply by 3, does the x match? You may not eliminate x. It doesn't work. Okay, look at the next choice. Okay, let's look at the y's. Okay, if I subtract, do you see here how they match up exactly? Okay, subtract. So we're going to eliminate y squared and y. I have to completely eliminate one of the variables so that when I do that, I only have one variable left. Okay, and I'm going to subtract. I don't actually need to scale it. I just need to subtract the two lines. Okay, subtract. Okay, second sentence, right? First, I decide I can eliminate by doing subtraction, and then I look at the resulting equation. Do I have only one variable? Yes. Can you solve it? Yes. Yeah, okay, solve it. See if you can make it all the way to the x and y coordinates. That will solve this thing I don't know how to graph. Okay. Isolate, factor, complete the square. Give it a shot. See what you come up with. By doing the first two sentences there really well, it makes the rest of the algebra much easier to follow. So that would be x. Then go back and find y. Yeah, I'd probably use the first one.
Yep.
So you can take it out.
-4, -4. So you get -4.
Now, if I'm solving, I would just divide by -4. I am now solving, which means I can divide both sides by -4. I could factor it out, but I can also just divide that number. Okay. So I'm going to start by trying to factor because I notice that everything divides by -4. I actually can factor more. Well, it's going to be a tangent solution because it's a repeated factor. I still don't know what these graphs look like, but I do know that it's going to be a tangent point where they cross. Okay, so we end up with only one x coordinate. That's it. I just get one x coordinate.
You get that?
Because it ended up being a perfect square trinomial when I factored. Okay.
Wait, how'd you get x equals negative?
You said each
Oh,
factor to
so-
0. Yep. Okay. Now, I'm going to choose to go back to the first line because those coefficients are slightly smaller than the second line. You still got to go find your y coordinates. I'm relying heavily on you remembering how you're supposed to solve a system, like first find the x coordinate, then find the y. We are trying to figure out which method's going to get us there best.
Yep.
Okay, so we get 2 times 1, so that's a 2. Okay. Okay. I get 2 points that happen to be tangent solutions. Now, how would I check my work? I would go type it in Desmos and just look at it. I'm not graphing these by hand, right? I don't know how to graph that. Okay, so I'm going to type it in so you can see what it looks like. See if you can follow those steps all the way to those x and y coordinates. Okay. The nice thing about Desmos is you don't have to solve for y. You can just type it in exactly as you see it. 2x squared. You can't type it like this in your calculator. Okay. It's an ellipse. Look at that. It's a squished circle. Okay. That's the best way to think of it. The radius is different in the x and the y direction. That's what makes it an ellipse. That's why my coefficients are different. Right? The stretch on the x and the y is different. That's why it's an ellipse instead of a circle. Plus 14x plus 6y. So what would I do if I'm at home? Okay. I would graph it and I would look to see if I'm on the right track. Did I at least find half of my coordinates? Okay, so I'm going to zoom in. Okay, right, see, that's a tangent point, guys, right there. It sort of bounces off. Okay, it's hard. I'm trying to find it. You got to click. Maybe I have to zoom in a little more. Look, there, okay. Ah. Okay, sometimes it's hard to see. Okay, it's there. It's just not showing it to me right now. There we go. There it is. Okay, -1, -4. There it is. And there's the other one. It's gray. It popped up right here. -1, -2. Okay, let's do another one for elimination, and let's see if we can't figure out how to set it up. Y equals x squared minus 9 x squared plus y squared equals 9. Okay. What
would you choose and what would it look like? Now, there's a lot of choices. That's what makes this hard. There's 3 choices. Substitute like this, substitute like that, or eliminate x squared. Consider those 3 choices and pick one. See what it looks like. 2 of those are good choices and 1 of them is a bad choice.
Elimination is a bad choice.
It's not. 1 of those substitutions is a bad choice. You tell me which one is the bad choice.
One the most on the left.
Well, okay, why?
It's squared, the whole thing is squared.
The substitution choice on the left, which appears to be the simplest to start with, my first sentence seems reasonable. But what happens on the second sentence? If I substitute like this, what is it gonna look like? It's got a square on the whole thing. My second sentence is not very nice. See that? Does that look ideal? A square and a square? That's a 4th degree, guys. You don't know how to solve a 4th degree equation yet. Next unit. Okay, but not yet. I don't know how to do that. Guys, you have to consider both sentences. Can you easily isolate? Yes. Can you solve after you do that substitution? No. I don't know how to solve that. You need to make a different choice. Okay, let's consider this one. Okay, can I make this substitution? Yeah, that was pretty easy to isolate. Now notice I isolated x squared. I don't care what you isolate. Doesn't matter. Okay, can you substitute it? Y plus 9 plus y squared. Yeah? That seems like it's just quadratic. I can solve a quadratic. That was a good choice. Okay, cool. Go for it. Okay, right, there is 2 good choices here, but you need to recognize when a bad choice happens so that you pick something different. Notice I haven't made it to the actual solving of the problem yet. I've just looked at the 2 sentences. Can I easily isolate? And what happens when I do the substitution? Okay, last one. Can I choose isolation or elimination? Well, I do see like terms, and I'm going to rearrange it and line up my columns. Y equals x squared minus 9. So I need to rearrange this. Notice that all I did is I moved this x squared to the other side. Look at how I lined it up. I think I can add those 2 equations together and I will eliminate x squared. What happens when we do this? I'm adding. Seems fine. Okay. Pick second column or third column and get all the way to your points. They might not be. Oh, they are integers. They should be integers. They should. At least one of them should be.
That's actually. Let me just like look past them, and they think it's staying up there, right? And then like, after like 5 minutes they realize they're looking past, and then they look around and I watch eye contact with humans. That's what I look behind.
I'm pretty sure that these are not points because we have a negative. So it should be plus. That's what we should do. This one, if you really point, I don't think this one steps. Imagine plus or minus.
So we're gonna look at what happens.
Yeah.
So isolate, factor, or complete the square. What would you do?
Y squared plus y.
That's it. How do you solve this? Isolate, factor, or complete the square.
Even if you don't put anything.
But there's no number.
Yeah, it's a 1. Wait.
But if it's plus 1, then that would change it. Isn't it plus 0?
It's this. Redistribute, see what you get.
So weird.
So you get y equals 0.
I guess you follow that with zero.
Why isn't it? How is this the same as this?
It's not.
Why did I care? It's all from like this side.
Which one are we looking at?
I did something like this.
Okay, so y plus 9 plus y squared equals 9. So let's combine our like terms. You should end up in the same place. So if you pick a good method, it very quickly comes to the same work. So factor the y out. You still get y equals 0 and negative 1. And then I go back and find my x. Okay, so 0 equals x squared minus 9. X squared equals 9. Be really careful. That's a plus or minus 3. Negative 3, 0. 3, 0. Okay, so I have 2 points. Next. And I'm going to put this in Desmos and check it. I happen to have 4 solutions. That's what it looks like. X equals plus or minus 2 root 2. Okay, so 2 root 2, comma, negative 1. 2 root 2, comma, negative. And now I'm like, gosh, is that really a circle and parabola that cross 4 times? Okay, well, let me check. Okay, let's see what this looks like.
That's not what she said.
Okay. Whoa. Okay, x squared plus y squared equals 9. Okay, so let me just scooch this. Okay. Okay, there's my circle. Seems okay. All right, y equals x squared minus 9. Oh, look at that. 4 points popped up. Okay, good. Seems okay. Look, notice that I got the right y coordinates and that the x's were non-repeating decimals, irrational numbers. Okay, so you can at least go in and check to see if you are on the right track. All you're doing is writing down what are your first 2 sentences. First, substitute x equals minus 3y. Second, what would it look like? That's it. All I want you to do is 1 and 2. Don't actually solve it. Just make your decision and look at what the result would be. Okay? You've got to figure out how to predict which choice to make. Oh, I just wrote it backwards again. Okay, I'm going. I can do it.
Wait, so you did the same for 2 and 4 as well?
No, 2 and 4 is a different question.
So should we just not?
Yeah, just start here.
Dear students and staff, this is Mr. Hood. In the spirit of Thanksgiving, I wanted to take a moment to thank you all
I am
for
not
helping to
done.
make Madison a welcoming school. I hope that you take a moment over the break to thank someone in your life who has done something for you. Lastly, I also hope you get the opportunity to relax and spend time with family and friends. Have a wonderful Thanksgiving break.
Okay, that's it, guys. Tell me what you would do and what it would look like.
Instagram plugin, guys.
Oh, substitute.
Mine's literally my name, an extra E underscore TK. That's the problem. No, well, that's not.
Oh, nope. Guys, come on, you can do it. Ah, there is 2 choices for number 8. Pick one. Pick one of the choices and figure out what it would look like. The only way you get better at making decisions is predicting what the first 2 steps are. Okay? That's all I want. And then whichever one you pick, tell me what it looks like.
I said, just kidding. This was dope.
No, don't solve. I just want you to do the first 2 steps. So like if I were going to say eliminate X, I would be like, oh, multiply by 17 is what I would need to do. That's all I want.
Mr. Breezy, real quick,
Yeah,
for the first
you
one.
just plug them in and see if it works.
Yeah, like,
This is checking a point.
oh,
Yeah. All right, guys, you got 5 minutes. Use them.
these studies,
So when we get back, we're Word problems has a lot to do with characters. Like for DLC, it's
I don't like, but I don't know. Yeah, he was talking to like this.
It's gonna be placed into the
so
we've got 3 lesson days when we get back.
Okay, I'm
I
gonna
wrote
text
down
you
right now with this chunk, then we're gonna sort of
some throw kid.
Okay. So you wanna be able to
Maya,
close the please about you guys when we get back. Maybe look at them, if you don't, you gotta make a schedule. Characteristics, it isn't even special lesson, it's literally just
Kilman.
asking for.
Kilman.
Wait, we have to do this.
Yeah, where is
Oh,
it?
that's disgusting.
Where are the exercises? What are the roots? We learned all those things specifically in the graphics, and now I'm not gonna say it's asking for a graph.
Where did my
Ask
pencil
where
go?
is it?
Hey, I feel like you stole my pencils because you're always taking stuff off my desk.
You take stuff off my desk more than I take stuff off.
Okay, here we go. Number 10, x squared, y squared, y. Oh, I would have to do substitution. X equals, that is your, right, I put down when there is 2 choices. Okay? What would it look like?
Oh, wait.
Ooh.
Not the next one yet.
Yeah, well, you could do either. Substitute y equals 12x squared plus 3x, or I could choose eliminate y by subtraction.
I'd eliminate 14.
And 14 is definitely elimination.
Hey, I'm
Okay. Guys, you gotta make the right choice to even be able to start the problem. Alright, first thing back, I'm gonna put you guys in groups and you're gonna solve systems when I see you next week. Alright?